Hello, students. So, I said in the class that I would be, uploading one video. I know I'm very late, but so nevertheless, I thought I'll take a live class at this time at 10 o'clock. But I was not sure how many of you would join, so I thought let me just make a video and post it on the group. That'll be helpful for most of the people, either which ways, like if you're joining or not. All right. Anyway, so I'll be discussing around 7 to 8 questions. All right. So very carefully, after you watch the video, try to practice the 7 to 8 questions. All right, and then whatever other things you quickly revise. So tomorrow's paper is comparatively very easy. So all of you know most of the things. So try to focus on every question which you're doing tomorrow. You'll easily get above 70. Easily. It's not difficult at all. If you, of course, if you study, that is. Like if you know the basics and if you are able to apply the concepts. Anyway, so let's begin. So the first question is that, so we got a, okay, let me just, so we got a bob. Okay, we got a bob here. Bob as in like the ball or whatever you have studied in the 11th class. Something like a ball connected to a string. Okay, and it is attached to the ceiling. All right. Now there is some charge on this. Let us say there is some plus charge, and it has some mass also. Right? It has some mass also. Now, if I keep this entire setup in the electric field, that is like this. So it is not. So electric field direction is not given actually. I'm taking it here. You can take it the other way around also. So electric field is given like that, and it's a uniform electric field. So basically, we have put this entire setup in a uniform electric field. All right. So then after some time, so because of the electric field, the bob will move to this point. It will make some angle theta and it will come to rest. So at this point, it is at rest. Okay, it is not moving. It comes till here and it stays at rest. Okay, that means it is making angle theta and stays at rest. So the question is, what is the angle theta you have to find? When the bob reaches here, what is the angle theta you have to find? Okay, simple question. So let us draw this figure once again. So initially it was like this. After we put this in the electric field, it comes to this point, making an angle theta. Okay. Now, how many forces are acting on this bob? There are multiple forces. So one force is a tension force that is acting away from the object. Then we have mg. Then, because the electric field is in this direction and it is positively charged, see, positively charged, in this direction also, so let me just remove this big line, this direction we are going to have Q into E. You know this force is equal to charge into electric field. You should know this, right? Any other forces? No other forces. Now let us resolve tension. If this is theta, this also becomes theta. So this becomes T cos theta, and this side you get T sin theta. This we have done a lot of times now. Okay, so because it is at rest, the force on the right side should be equal to force on the left side. Force at the top should be equal to force that is acting in the bottom direction, right? So T sin theta, okay, this side force I'm taking, T sin theta is equal to charge into electric field. And T cos theta is equal to, this upward force is equal to M into G. Now if you divide these two, T and T will get cancelled and we'll be left with tan theta is equal to QE divided by M into G. Okay, what is the value of Q and all? So if they have not given any value, you can say theta is equal to tan inverse QE by mg. That's it. This is the value. Okay, otherwise if they give you some values, for example in this question, say if the charge value is given as 339.2 into 10 power minus 10 coulombs. Alright, mass value is given as 8 micrograms. Micro means this is 8 into, micro means 10 power minus 6 kgs it will become. Alright, and then electric field value, if it is given as 2 into 10 power 3 volts per meter. Put this values here, you get tan theta is equal to these values when you put 39.2 into 10 power minus 10 into 2 into 10 power 3, that is the electric field. The value of mass is 8 into 10 power minus 6, and the value of acceleration due to gravity you can take it as 10. So I'm simplifying this. I'm not going to simplify it now because we have to solve other questions also. You'll get approximately 0.98 approximately equal to 1. So that will give you theta is equal to 45 degrees. Okay, theta will be equal to 45 degrees. So easy question. Next move on. Let's move on to the next question now. So say we got a hemisphere. Okay, we got a hemisphere. Let me just cut this portion. So hemisphere is half of sphere. Okay, hemisphere is half of sphere. So basically here you don't have anything. Inside you don't have anything. It is completely hollow. Alright. So on this you got a positively charged or you got positive charges. And these charges are distributed uniformly. This is center of the hemisphere. Okay, radius of the hemisphere is given as r. The question is in which direction the electric field is going to act for this hemisphere. Now see, if you take the small dq charge, alright, so here the electric field is going to be in this direction. If you take exactly symmetrical charge to this charge, say this is exactly symmetrical, alright, so this will be somewhere like this, something like this, yeah, something like this. Let us put, okay, alright, let us take a reference as a horizontal line. So if this is theta, so this will also become theta, then resolve it. So this becomes what? So if this is E and this is also E, or DE rather, let us call it DE, then this becomes what? DE cos theta. This becomes what? This side DE cos theta. In the vertical direction, you will get two components. One for this, that will become DE sin theta, and one for this, that will also be DE sin theta. D sin theta, D sin theta. So like that, all the D cos theta components. So if we consider this half, so for this half, all the D cos theta components will be on the right side. For this half, all the D cos theta components will be on the left side. They'll get cancelled. And for all the charges, DE sin theta components will get added up. So E is equal to integration of DE sin theta. But in the question, he is asking only the direction. So all this you don't have to do. So what direction are you getting in the end? You're getting a direction that is downwards, perpendicular to the diameter. Okay, downwards. This is the direction of net electric field, perpendicular to the diameter. All right, that's it. Fine. Next. All right. In the third question, so we have uniform electric field, okay, acting like this. Okay, vertically downwards. Now if we have an electron, or say vertically upwards, let us take. See, basically the question is that electron falls down. He has not given the direction of the electric field. He's saying electron falls down. Now how will the electron move? So if the electric field is in the upward direction, then electron will fall down. No, fall down means what? Falls means what? Falls itself means it is going down only. So electron will go in the downward direction only if the electric field is in the upward direction. See, you know this. Electron always moves in the direction opposite to electric field. Okay. So let us say that it is moving. In the question it is given that the electron moves for a short distance. Say height h. It from here to here it is moving when the electric field is in the upward direction. Now it seems that we reverse the direction of the electric field. Okay. In the question it is given that we reverse the direction of the electric field. And now instead of, and the value is same exactly as the first case. And now instead of electron, we let proton fall down. Okay, this is a proton basically. It's a proton. We let a proton. So proton moves in the direction of the electric field. You already know this. So the question is, which particle, electron or proton, which particle takes more time to cover the same distance? So if this electron is taking traveling down by h distance, this will also travel down by h distance. So how do you solve this question? Now see, one thing you have to understand here. Okay, first of all, the charge of electron, okay, let us say charge of electron and proton, so let me write P here, charge of electron and proton is same. What is the value? The value is 1.602 into 10 power minus 19. Magnitude wise they are same. For electron it is negative, for proton it is positive, that's it. But magnitude wise it is this value. What about mass? So mass of electron, okay, and mass of proton, is it same? No, it is not same. So I'm not putting the values here. I mean, of course, you can take the values also. 9.1 into 10 power minus 31 it is for electron. And for a proton, it is approximately 1.6 into 10 power minus 27 kgs. So you can see here, don't look at 1.6 and 9.1. Look at the power. This is 10 power minus 27, it is 10 power minus 31. So it is basically proton, mass of proton is approximately 10,000 times the mass of electron. That means proton is heavy. Okay, mass of proton is much greater than mass of electron, 10,000 times approximately. 10,000, yeah, 10,000 times. Okay. Now, what was I telling you? Yeah, so we have to find which particle takes more time. That means, suppose say Tp is the time taken by proton, okay, to fall, time taken by a proton, and Te is the time taken by an electron to cover how much distance? H, same distance. Then which one is greater? You have to see. How do we see that? So see, if both of them are released from rest, okay, this is released from rest initially, and this is also released from rest. Okay, released means initial velocity is 0. So in both the cases, initial velocity is 0. You have to use simple kinematics. S is equal to ut plus half at square. Okay, so for let us consider electron. So he, distance traveled by the electron, is how much? H. Okay, H is equal to how much? U 0 for both, because they are released from rest. So 0 plus half into acceleration of electron into time taken by the electron. Okay, what about HP? It is, the distance is same or displacement is same, and is also released from rest. So 0 plus half into AP, acceleration of proton, into time taken by the proton. Okay, distance or displacement is same for both. It is h and h. That is given in the question itself, right? Now, what about the acceleration? So finally, let us, if we call this 1 and if we call this 2, we have to find time, okay? But what about the accelerations here? So acceleration, how do we get? From force. So what is force? Equal to mass into acceleration. In this case, what is force? See, there is no gravity, okay? No gravity in this question. There is no gravity. We have only electric field. So electric field magnitude is same in both the cases. So electric field is here in the first case, I mean electron case, it is in the upward direction. For a proton, it is in the downward direction. But the value is same. Okay, E and E. So how do you find force when only electric field is given? So force is equal to Q into E. This you should know. Force is equal to charge into electric field. So F is equal to mass into acceleration. But in this case specifically, it is charge Q. I'm just representing charge with letter Q, and electric field. Charge into electric field. Okay, so from here, what can we tell about acceleration? So mass into acceleration is equal to Q into E. Acceleration is equal to Q E by M. Okay, charge into electric field by M. So if it is, if you're talking about electron, then in place of Q, I'm going to put E. And in charge of proton, I'm going to put the charge of proton. But charge for proton and electron is same. So let me just use E only for both. Doesn't matter, we just care about the magnitude here. So if I write H for the first equation, H is equal to half into E, okay, by ME. Okay, this is for electron, into TE square. I'm going to divide it. Okay, second equation I'm going to divide. Half into, what are we getting here? E. Why E? Because the charge is same. I'm using E only here also. E divided by MP. Mass is different. And time square. So half will get cancelled. Small e and capital E will get cancelled. H and H will get cancelled. So what will be left here? See, here you'll get 1 is equal to, I'm writing here this side, 1 is equal to MP by ME. When you take the reciprocal up, it will become MP by ME into TE square divided by TP square. Okay. Now if you take it to the other side, I'm just putting the answer directly, answer as in the equation directly. TE by TP is equal to under root of ME by MP. Okay, now look at this equation. I'm writing the final conclusion here. See, from this equation, what can we conclude? That time is directly proportional to the root of mass. That means more mass, more time. Less mass, less time. So whose mass is more? Proton's mass is more. Mass of proton is greater than mass of electron. That means time taken by proton should be greater than time taken by electron. It should be more. If time taken by proton is 5 seconds, time taken by electron will be less than 5 seconds. Something like that. Okay? Alright, fine. Let's move on to the next question now. So, now in the next question, once again, let me just read the question for you. Alright, so it is given to us that there is electric field parallel to y-axis, like this. Electric field parallel to y-axis. Okay, the magnitude of the electric field is 10 power 3 volts per meter in the upward direction. Okay, and we are releasing a particle of mass m, I'll tell you the value of mass, along the x direction. We are releasing the particle in the x direction. Where is the electric field? in the y direction, and we are projecting a particle in the x direction. Of what is the mass of that particle? Mass m. With how much velocity we are projecting it? 10 meters per second. This is the initial velocity. 10 meters per second. Okay. So mass of the particle is given as 1 gram or 10 power minus 3 kgs, and charge, it has some charge also. This particle has some charge also. The charge is given as 10 power minus 6 coulomb. You have to find, okay, you have to find the speed of the particle. Find the speed of the particle after 10 seconds. Find the speed of the particle after 10 seconds. So how will you solve it? See, easy, see. Now this particle is released, or it is projected in this direction, x direction, okay? But electric field is in the vertical direction. This charge is positive or negative? It is positive. That means it has to move along the direction of the electric field, okay? But it is projected in the horizontal direction. So it is like this situation, you can compare it to, you know, a case when you're throwing a particle, gravity you learned. So in the first chapter, kinematics, when you throw a particle from the top of a building, okay, from the top of a building with some velocity, okay, when you throw it in the horizontal direction, we can say that ux is equal to u. Ux means initial velocity in x direction. What about uy? Does this velocity, does it have any component in the y direction? No. So uy is equal to 0 meters per second. Initial velocity in the y direction is 0. Initial velocity in the x direction is the velocity with which you are throwing the particle. And what about acceleration? Ay you have. What is that? Minus g. Minus because it is always acting in the downward direction. And ax will be 0. Why? Because there is no force. Since force in the x direction is 0, I told you that only when there is force you'll have acceleration. Okay. Now let us compare. Let us start doing for the electric field. Here also we don't have gravity. Consider there is no gravity. Okay. We are not taking mg and all that here. Now see, this particle is projected along the x-axis, right? So what is ux equal to? Ux is equal to 10 meters per second. Okay, it is projected along the x-axis. So what is uy? 0 meters per second. There is no component in the vertical direction. Alright. Now here, is there any force acting in the x direction? So force in the x direction is 0 newtons. There is no force acting in the x direction. There is no force. Because there is no force, acceleration in x direction is how much? 0 meters per second square. When there is no force only, what will the acceleration be? 0. Now if the acceleration is 0, suppose say let us take Vx is equal to ux plus ax into t. But what is ax? 0. So what will you get? Vx is equal to ux. That means velocity did not change. After 10 seconds also, the velocity is going to remain 10 meters per second, or speed is going to remain 10 meters per second. Alright, so this you must have understood now clearly. So Vx is equal to ux because ax is 0. Why is ax 0? Because there is no force acting in the x direction. Okay, Vx is 0. Okay, is the answer over? Is the answer 10? No, he's asking find the speed of the particle after 10 seconds. See, after 10 seconds, the particle, so how will the particle move first of all? Will it move in the straight line like this? Or will it move in the straight line vertically upwards? No, it will move something like this. The particle is going to move something like this in this trajectory, on this trajectory. Why? Because it has both x component, okay, it has both x component and y component. So basically, this you should know. The particle is going to move along this trajectory. Trajectory means path. Okay, along the path, along the shown path, blue color path. Why? Because acceleration is acting upwards. Okay, acceleration is acting upwards, but the particle has some velocity in x direction also. The particle has some velocity in x direction also. And but the acceleration is acting in the upward direction. So it will have velocity both in the upward direction and x direction. Upward direction, x direction. Upward direction, x direction. So the net velocity is always going to be tangential like this. Okay. Anyway, so after some time, after 10 seconds, the particle may be somewhere here. So it will have both x and y components. So x component we got. What about y component? Now let us calculate the y component. So what about y component? Is there any force acting in the vertical direction? Is there any force acting in the vertical direction? Yes, there is electric field, right? So Fy is equal to Q into E. E is acting in the vertical direction only. So Fy will be there in the vertical direction. Fy is equal to Q into E. Alright, so what is the mass? What is the force equal to? Mass into acceleration in y direction. So that is Q into E. So what is the acceleration value? QE by m. Okay. So do we know the value of charge? Yes, put that value here. 10 power minus 6 into electric field value is 10 power 3 divided by what is the mass value is given as 1 gram, that is also 10 power, sorry, that is 10 power minus 3. So this goes up, it becomes 10 power 6, so this value becomes 1 meter per second square. So therefore, what is the acceleration in y direction? 1 meter per second square. Okay, there is acceleration. Why? Because there is force. In this case, there was no force. When there is no force, acceleration is 0. So initial velocity is equal to final velocity. But in this case, you can't do that directly. So Vy is equal to Uy plus Ay into t. This we are going to use. See, kinematic equations are applicable only when the acceleration is constant. Is the acceleration constant here? Yes. Why? Because the electric field is uniform. Had electric field been non-uniform, then we could not have used this. Anyway, so what is the value of Vy? So Vy is equal to Uy is how much? Uy is how much? Uy is 0 meters per second. Why? Because in the beginning, when the particle was projected, it was projected only in the x direction. Alright, so this is 0. Alright, A is what? 1. And time is how much? After 10 seconds you want to find. So time is 10 seconds. So here what are you getting? Vy is equal to 10 meters per second. Vy is also equal to 10 meters per second. So what is the net velocity? So let me just put that here. I'm not erasing anything. So V net in vector form is equal to, otherwise let me erase it. Erase what? Maybe this part. Or let me write here. No, why erase? Let me write here. So V net is how much? V net is after 10 seconds. So okay, this is after 10 seconds. After 10 seconds. V net after 10 seconds. So Vx in I cap direction and Vy in j cap direction. So what is the value of Vx? 10. So 10 I cap. What is the value of Vy? 10. 10 j cap. So what we want to find the speed. We don't want to find the velocity. We want to find the speed. Speed means what? Magnitude of this vector quantity. So this is going to be equal to 10 square means 100 plus 10 square is 100. So you get 2 into 100 or root this 10 just comes out 10 into root 2 meters per second. This is what? This is the net speed. Net speed. Final speed after 10 seconds basically. That is our answer basically. Right? Alright, fine. The next question. So in the next question, it is given to us that there is a dipole. So it's the fifth question. There is a dipole. Okay. So let us consider this as minus q and this as plus q, which is, and the the distance between them is given as 2 centimeters. So there is a dipole. The value of charge is given as 0.1 microcoulombs. Distance is given as 2 centimeters. All right. And electric field is also given to us, and that is 10 power 5 Newton per coulomb. He is asking us, when these three values are given to us, what is the value of maximum torque? What is the value of maximum torque? Okay. So how do you solve this question? So first of all, what is torque? Torque is equal to P cross E in terms of dipole moment, because dipole is given to us. I'm taking this value. Torque is equal to P cross E, which is equal to, or let us just take the magnitude. This becomes P E sine theta. Okay. So when do we get torque maximum? So torque maximum we get when theta is equal to 90 degrees. In yesterday's class we saw this. So that gives us torque maximum. So when you put 90 degrees here, because see, sine theta for maximum value of torque, sine theta should become plus 1. So when will it become plus 1? For theta is equal to 90 degrees. So torque maximum became what? P into E. So what is dipole? Charge into distance. So charge into distance, that is dipole moment, into E. So what is the value of Q? Value of Q is 0.1 micro. Micro means what? 10 power minus 6. So 0.1 microcoulombs into distance is how much? 2 centimeters. So convert this to meters. 2 into 10 power minus 2 meters you'll get. So 2 into 10 power minus 2. And finally, the electric field value is 10 power 5. Alright, so on simplifying this, you'll get 2 into 10 power minus 4 Newton meter. That's it. Simple. This was a very simple question. Fine, next question. Sixth question. Okay. So we have a dipole again. So we got a dipole here, minus q plus q. So there are 2 points. One point is given on the axis of the dipole. Let us call this point A. Okay, let us call this point A. And the electric field here, due to the entire dipole, is given as EA. And the other point is on the perpendicular bisector, somewhere here. Okay, and you should know the direction basically. And the electric field is given as EB. So let me just put that here. Electric field is given as EB. Now from okay here. So the point is that from the center they are both at the same distance. So here, okay, let me just redraw the entire figure. So minus, plus, minus q, plus q, there is this axis here, and there is a point on the axis. Let's take that somewhere here, and then we have a perpendicular bisector, and there is a point here at the perpendicular bisector. At that point the electric field is given as EB, and on the axis the electric field is given as EA in this direction. Okay, they both are at equal distances from the center. So if this is x, this is also x. So you need to tell me the relation between EA and EB. You have to tell me the relation. Relation means EA is equal to something into EB, something like that you should get. So simple, very easy question. See, electric field on the axis is given as what for a dipole? K into 2p divided by x cube. Okay, for the equator, so that is this point, EB. So EB is how much? EB is how much? EB is equal to K into, I'm just taking the magnitude, P divided by x cube. So you know this, so if you divide this, EA by EB if you do, you get what? So K and K will get cancelled, x cube cancel, PP cancel, you get 2. So EA is equal to 2 times of EB. EA is equal to 2 times of EB, that's it. So, okay, if they ask you with the sign, then you have to put minus here, and you have to put plus here, then you'll get, with the sign, you'll get EA is equal to minus 2 times EB. Okay, fine. For now, the answer is EA is equal to 2 times EB. Anyway, next question. So, we got a uniform electric field. This is the 7th question. This is the last question for now. So, we got a uniform electric field. We got a particle of charge q and mass m. And we got another particle of charge q and mass 2m. So, after time t, so both of them are allowed to move for time t. After time t, what is the ratio of their kinetic energy? So if I call this particle 1, if I call this particle 2, k1 by k2 is how much they are asking. K1, k2, kinetic energies. What is the ratio of their kinetic energies after time t? So how will you solve this? See, electric field is given as E. Okay. So calculate the force on the first particle. So on the first particle, the force is what? So let me call this one. The force is going to be Q into E. Okay, on the second particle, what is the force? Q into E, because charge value is same for both. So the magnitude of the force is going to be same for both. What about the accelerations? Will that be same? Obviously, they won't be same. Why not? Because see, when I write force is equal to mass into acceleration, acceleration is what? Force by mass. If force is constant, if force is same, it implies that acceleration is inversely proportional to mass. That means more mass, less acceleration. Less mass, more acceleration. Okay, force, all the force is same. Force is constant. So acceleration in that case is going to be inversely proportional to mass. That means if we take m and 2m, which is greater mass? 2m mass. So more the mass, less the acceleration. That means for this particle, for particle 2, the acceleration will be less. How much less? Easy to calculate. Let us see. See, we have force is equal to mass into acceleration. So I'm writing F is equal to m1 into a1. Okay, f1 is equal to m1 into m1 a1, and f2 is equal to m2 into a2. But f1 and f2 are equal. They are both q into e only. So let me call this f. Let me call this also f. Okay, so basically we have f is equal to m1 into a1, f is equal to m2 into a2. Okay, let me write that once again. So we have f is equal to m1 is m into a1, and f, because force f1 and f2 are equal, 2m. What is m2? 2m into a2. Take the ratio, ff cancel, cancel. So what are you getting? 1 is equal to a1 by 2a2, or a1 is equal to 2 times of a2. a1 is equal to 2 times of a2. That means the acceleration of first particle, if it is a1, and if the second particle acceleration is a2, acceleration of a1 is greater than twice of a2. So let us say, let a2 is equal to a. Let us say a2 is equal to a, then a1 will be how much? 2 times of a. Okay, remember this. a2 will be 2 times of a. Now again go back to kinematics. Okay, keep this in mind. So let me copy it and paste it up. Somewhere up. Okay, one second. So yeah, we got this value. We got the relation between the acceleration. Now see, again we have to go back to kinematics. Why? Because we want to find the speed. See, what is kinetic energy? kinetic energy is half mv squared. Do we know the value of v? We don't know. That's why to find the value of v, we have to use kinematics. Okay. So suppose both the particles are starting from rest. Starting from rest means what? Initial velocity for both the particles is 0 meters per second. Then how are you going to find it? So v is equal to u plus 80 if I use. V is equal to u plus 80 for both. Okay, so let us one by one start using it. So v1 is equal to u1 plus a1 into t. But u1 is how much? 0. Because for both the initial velocity is 0. So v1 is equal to 0 plus a1 is how much? A1, where is a1? A1 is 2 times of a. So 2 times of a into t. What is t? T is t only. So let me put t. So you will get v1 is equal to 2at. Okay, v1 is equal to 2at. What about v2? So v2 is equal to u2 is 0. So I'm just putting directly this value of u2. a2 is how much? A2 is how much? A2 is simply a into t. So v2 is equal to how much? A into t. Now if you compare this and this, v1 is how much? 2at. v2 is how much? 80. So what are we getting here? So if I call this value, v, this value will be what? 2v. Here once again, if I call v2 80, v2 which is 80 v, then 2 times of 80 will be what? 2v. So this is more important. So finally, v1, you have to consider v1 is equal to 2v and v2 is equal to v. Remember this, v2 is equal to v. This and this you have to consider now. So what is kinetic energy? So let me just remove this part. So kinetic energy finally for K1 is going to be what? Half into m, because mass is m for first particle, into v square. v1 square, sorry. v1 is how much? v1 is 2v. So I'm writing 4v square directly. Okay, divided by k2. k2 is what? Half into m into v square. Is it v or not? Yeah, that's it. So half, okay, 2m. See, we made a mistake here. Mass is 2m. Okay, half and half cancel. M and m cancel. Okay. So k1 by k2 is what? V square cancel. 4 by 2, which is equal to 2. Therefore, k1 by k2 is equal to, that means the ratio of kinetic energy is equal to 2. That's it. Okay. Alright, so very carefully solve these questions once again. If you can solve it, just go through once. I would definitely suggest you to solve once again. And all the best for tomorrow's exam. And once again, really sorry I'm uploading the video very late. So at any cost, try to watch it. Thank you.